Hi, dear students. A warm good morning to all of you. Welcome to the next session of Chemical Bonds and Biomolecules. Among the non-covalent bonds that which we come across, one among them is the van der Waals forces. But what is the van der Waals forces? If you go to take a particular substance within the atom, what happens? The electrons are being moving in a random motion with each other, and a sort of Brownian movement, a fast brisk movement happens between by the particles within an atom. And when these particles come randomly close to each other, uh, sometimes the electrons will be localized in different places and all that. And based upon that, what happens? A force of attraction or repulsion comes in between them. And this force of attraction or repulsion happens only when these particles come close to a distance of about 5 nanometer, or sometimes we also explain it as 3 to 4 angstrom also to some extent. So when they come as close with each other, there exists a weak force of attraction or repulsion between them, and that is referred to as the van der Waals forces. And once they are being separated from, now they are randomly moving in all the directions. So when they are moving far apart, what happens? This bond breaks. Okay, and then again when they come close together, they have this force of attraction or repulsion. And the extent to which this attraction is possible is when they come in as close as a van der Waals radius, when they come in the proximity of having a van der Waals radius. Okay, if they are far away from that, they will not have it. So that's what is a van der Waals force. So you might think, what is causing this van der Waals force of attraction or a repulsion which happens to be between them? Now look at this particular case. Regardless of being polar or non-polar, we know in every atom you have a nucleus, and surrounding the nucleus there are the electrons. And these electrons can be either be symmetrically distributed around the nucleus at some times, but at the same time they might sometimes be distributed unsymmetrically. Now what do you mean by unsymmetrically? Now look at this picture. You can see the nucleus is here, and this is an atom. The electrons are moved towards one particular direction. So in such a case, what happens? Even if the molecule is not being found to be polar, because of this unsymmetrical distribution of electrons towards one side of the particular atom, a instantaneous or a transient, okay, uh, delta positive and a delta negative will be formed within it. So this is referred to as the formation of equal and opposite electric charges in a particular molecule. Okay, when the electrons from it are being unsymmetrically distributed, that is referred to as a dipole. So uh, the van der Waals forces which happen in between the particles, it is mainly being caused because of the unequal distribution of the electrons around the nucleus. Okay, so let me just explain to you. So this unequal distribution will result in the formation of a what? A delta positive and a delta negative nature at on either sides of the of an atom because of the unequal distribution of electrons, and that is referred to as a dipole. Now consider an atom which is having a dipole is coming in close proximity with another atom. Okay, sometimes uh, the presence of this particular dipole might induce the formation of some sort of dipole in the other, or in other. So that is also a type of interaction. That is also a case of van der Waals interaction. Or in another case, what happens is uh, two atoms which are having a dipole like nature, they might come in close to with each other. That is an example of a dipole dipole interaction. So the van der Waals forces mainly happens when uh, an atom which is having a dipole, okay, influences the formation of another dipole and attracts the thing, or sometimes it will induce the formation of a dipole in another atom which is coming in close proximity with the one which is having a dipole. But you should keep in your mind, or the formation of this dipole is being found to be what? It happens in fraction of seconds. Even in this dipole, if the electrons are moving fast and if the dipole might be sometimes being lost by some time. So when they vibrate, what happens? The van der Waals, the bonds will break and the electrons will get delocalized. So as the electrons are moving fastly as the Brownian movement within it, sometimes within atoms, dipoles can generate. And these dipoles, when they come into close proximity with the other atoms which are having a dipole or which are not having a dipole, the situations can vary. Some force of attraction happens between them when the atoms are at a distance of about 5 nanometer, and that is called the van der Waals forces. And when they rapidly migrate out, what happens? The vibration breaks and the electrons are delocalized, and what happens? The van der Waals forces will get lost. And again, if they come into close proximity and if there is a dipole, sometimes what happens? Again, the force of attraction happens. So I guess you got an idea about what is a van der Waals force and how does it get generated. So van der Waals forces, excuse me. So let's continue. The van der Waals forces, they are considered to be as weak, non-specific interatomic interactions, and they come into play when two uncharged atoms come as close as about 5 nanometer. And these are weaker forces and they are less specific than electrostatic and hydrogen bonds, and they become equally important in the biological systems. And as I mentioned earlier, the basis of the van der Waals bond is the distribution of the electronic charge around an atom uh, when it changes within time. And all van der Waals forces arises when the electrons of an atom get attracted by the nucleus of another atom. I hope that is clear to you. And coming into these non-covalent bonds or the van der Waals forces, they are of three types. Okay, you call them as three different types. Like it's nothing big, but you have two terms. They can be of three different types. Either they can be called as dipole dipole forces, or they can be called as the London forces, or they can be called as the induced dipole forces. Or these induced dipole is also called the Dipole forces. Now, let me just take you to a situation in which there are two particles which are having two polarized molecules. Of course, they are having a dipole with each other. That is, when they are standing separately itself, they are having a delta positive and delta negative nature. If these two polarized molecules come to each other, what happens? Then there is a force of attraction between them. What? A van der Waals force of attraction between them. In such cases, that type of van der Waals force of interactions is called the dipole dipole forces or the Keesom forces. Now, consider a next situation in which a dipole is being induced in an organism instantaneously. That is, not induced, randomly, not induced. Okay, okay. Organism is not organism, an atom. Sorry, an atom which is not having a permanent dipole because of the fluctuations of the electronic load, it would have temporary charges, and it forms a dipole. And when that comes in close proximity with another atom, uh, what sometimes what happens, it might uh, what does it means, it might transiently develop uh, another dipole moment when it comes into close with each other. So randomly or instantaneously, if a dipole moment, a dipole is being generated within two atoms which have been found close to each other, and it sometimes this charge distribution might also influence and transfer it to the next atom. In such cases, it will there is a van der Waals force of attraction, and that is called the London forces. So keep in your mind, when a dipole is being generated in an atom instantaneously, okay, and when another atom also comes into close proximity with it, it forms a sort of attraction with each other that is referred to as the instantaneous dipole induced dipole forces. So in this atom, instantaneously a dipole is being formed, and that is inducing the formation of another dipole in the next one, that is also happening instantaneously. In such cases, that is referred to as the London forces. Now you have a third case. If you have a molecule which is having a permanent dipole, okay, a permanent dipole, or it's a polarized molecule, and if that what is it, that permanent dipole molecule or the polarized molecule comes in close proximity with another atom which is not having a dipole moment, then it will induce the formation of a or dipole in the other one. In such cases, the van der Waals forces is called the Debye forces. Okay, so you have three cases of van der Waals forces. The first case is when two permanent dipole having polarized molecules, they come into close proximity and a van der Waals force of interaction happens between them. That is called as a dipole forces or the Keesom forces. Or the second case, you have a case in which a temporary dipole instantaneously developed uh, in one atom is or one atom, yeah, that is inducing the formation of another dipole in the a temporary dipole in the form of another atom, that is called the London forces. Or the final one is the Debye forces, when a permanent dipole will induce the formation of a what, a transient type of dipole moment in the adjoining atom, and that is referred to as the Debye forces. I hope you got an idea of these van der Waals forces, and these van der Waals forces do play an important role in biomolecules. That is, when they come in close proximity, they might have some sort of attraction and some sort of repulsion also, and these are the weakest intermolecular forces which are happening in between the molecules. And you can see a delta positive and a delta negative nature will be formed when the atoms at the side where the electrons have been found to be more dense, a delta negative will be formed, and where the region where the electrons are not being present or electrons are not being symmetrically distributed, you get a what, a delta positive nature. And these van der Waals forces, let it be of three types, as I mentioned, they are of three types. Three names are being given depending upon how they are being formed. Based upon that, these different types of van der Waals forces are there, and they do play an important role in the maintenance of the structure, as well as to make the integrity of the biomolecules do play is being influenced by the van der Waals forces. But keep in your mind, they are weak forces compared to the other non-covalent forces, and they can be lost instantaneously. I hope this is clear to you. We will continue with the next non-covalent bond, the hydrophobic interactions, in the next class. Thank you for now.